Hello friends, welcome back. So in this session we will try to understand what are enhancement mode devices and its applications. So at the end of the session you will be able to understand what is enhancement mode device and what are its applications. So in detail, yeah, there won't be any confusion. So please, I request to please watch the entire session without skipping any part so that it will be clearly understandable at the end. So before that, also please, if you are new to this channel, kindly watch, like, share, and subscribe to my YouTube channel. So and press the bell icon to get the latest updates or notifications. So let us quickly start with the session. So enhancement mode device. So usually we say that enhancement mode device, usually MOSFETs can be operated in enhancement mode. So this is the one thing which you have to understand. So MOSFET is a device which can be operated in the enhancement mode. So what is this enhancement mode? We will try to understand now. So commonly used type. So enhancement mode, we can say that it is commonly used type. So in this case, we have already studied about BJT, that is bipolar junction transistor. So in the similar way, MOSFET is also commonly used type is enhancement mode device. So enhancement mode is the commonly used type of mode of operation. Okay. So here it is normally off. So in the BJT also we have seen that it was normally in off state. So also in the case of MOSFET, we can say that it is normally off. Okay. So equivalent to normal open switch. So it is equal to whatever switch we will be using on our day-to-day life. It's a kind of open switch. So open switch means it's normally off. Okay, unless and until we press the switch, it won't be on. So it's kind of normally it will be off, but as and when we trigger or we switch on the particular thing, and in that case it becomes on or it enters the on state. Okay, so that is the one thing. Okay, so it does not conduct when gate voltage is zero. So now we will try to understand this in a very detailed way. So this is one of the diagram where enhancement mode operation is tried to try to explain. So here there are three terminals, as I said. So one more thing is, if you are not aware of this, if you want to know much in detail of all these particular symbols, so kindly refer to my previous sessions on MOSFETs and all, FET classification and all. So I have also posted it in my description link, so you can refer to those link and understand that, and then probably you can come back to this session. So that's also, I think, very important here. So but for time being, just I will try to brief again. So this is the diagram which we are seeing is a enhancement mode of a symbol. So as I said in the previous session, it's like if we can see, just to identify, shortcut trick to identify which whether the given, if someone gives the circuit symbol for MOSFET, so then how to understand, how to know or confirm whether it is a given symbol is a enhancement mode or the depletion mode. So basically, if we see this line, intermittent line, like dash dash and like this, so if we see kind of this one, then we have to make sure, say that it is an enhancement mode device. So this is the one trick which I have already explained, but still again explained. So this is if the arrow mark is here, then we can say that N type. I have also told this in the previous session. So in this case, this diagram, the given diagram is enhancement mode of N channel MOSFET. So this is N channel enhancement MOSFET. We can say that. So it has got three terminals. So as we can see, the first one is source, next is gate, and the next one is drain. So there are three terminals. So it does not conduct when gate voltage is zero. So unless and until we apply voltage to this gate terminal, So this there the channel won't be completed because it's as I told, it's in normally off state, right? So unless and until, what does it mean is, unless and until we provide some voltage at the gate terminal, the MOSFET will not get on. Okay, so that is one thing, key point which you have to remember. Next is the electrostatic field created temporary channel by the application of a gate voltage enhances the conductivity of a channel rather than the deplete the channel as in case of depletion mode of MOSFET. So don't worry about this depletion mode. I will explain it in the next session. So also, if possible, I will try to paste the link or this description itself. So maybe you can just understand that the electrostatic field will be created when gate voltage is applied. An electrostatic field or a temporary channel will be created by the application of this gate voltage, which enhances or increases the conductivity. So this is the case in case of enhancement, but in case of depletion it is different. So that we will not worry as of now. We will only try to understand enhancement mode of operation of a MOSFET. So also with the down diagram, this diagram, if we see, there are three terminals. So source, gate and drain. So here these are, and the down one is substrate and this is N channel, this one. So whenever we, unless and until we apply some gate voltage, this particular MOSFET won't get on. So unless and until we apply, it will not turn on. So that means it is normally in off state, as I said before. So once we apply the gate voltage, what happens is, so a temporary channel, as I told, electrostatic field will be created. A temporary channel will be created between the source and the drain. Here it's an imaginary line which we can just imagine over here. So this is the thing. There is imagine that there is some imaginary line here, so which is nothing but the temporary channel for the conduction, we can say. So it, when the temporary channel will appear, so it will only come into existence when we apply a particular gate voltage across this particular MOSFET. Okay, so in this way we can say that this enhancement mode device, in the enhancement mode of operation, so it is a normally off state of operation. So unless and until we apply the gate voltage, the MOSFET or the enhancement mode device will not turn on. So we can say, as I already told in the beginning, that the behavior is similar to as compared to BJT, bipolar junction transistor. So when it comes to BJT, I have also conducted one session on BJT. Please refer to that particular session if you are not aware of this BJT. What does this BJT mean? So yeah, please refer to that. So behavior is similar to bipolar junction transistor. That means our BJT is also in a normally off state, but unless and until we apply some base, there is some, I mean, it is a, basically we can say that it is current control, we can say. Yeah, but this kind of MOSFET or FET, we can say, basically it is a voltage control device where the operation wholly depends upon the application of gate voltage. That means it is a, if it is controlled by voltage, then we can say that it is a voltage control device. Okay, so that is the main thing which we can understand here. So ultra fast switching capability with high conduction. So in case of enhancement mode device, what is the advantage we can see? So advantage, what we can see is switching will be very faster and with high conduction will also be high, as and when we apply the gate voltage, the conduction increases between this source and drain, where an imaginary or the temporary channel will be created in between this source and drain, and there will be a continuation in the flow of gas. Yeah, so this is about enhancement mode advantage. So what is the advantage? It is having ultra fast switching capability, and as also it has got the high conduction. So now we will try to understand what is the this one, this applications of enhancement mode device we will try to understand now. So first one, which we are already aware, electronic switching circuits, because as I already told just now that the switching capability is more, then definitely that advantage will be converted into an application where it is used in electronic switching circuits. Okay, so this is very important thing. In any of the switching circuits in electronics, it can be used. So next comes motor driver ICs, where an IC used to drive the particular motor is used. So there also we can use this enhancement mode. So basically, or usually we will say MOSFET. So that is the another application, and also in power electronics ICs. So we can say that power electronics ICs means it's there are many power electronic devices. So in those, if it is ICs will be available. So in that also we use or we prefer usually this enhancement mode devices or enhancement mode of operation. So and also in digital controller ICs, so there are lots of digital controller ICs where it finds its application. Okay, enhancement mode of operations. Yeah. So next is amplifier circuits, where we are already aware like what is amplifier. So and also in inverter circuits. So these are commonly where it finds a common application, or many it's used basically in almost all the circuits, we can say. And do remember that the advantage of enhancement mode of operation is it has got actually high conduction. Okay, and also faster switching times, we can say. So this is all about enhancement mode device. So just we will quickly revise once. So basically, as I in case of FET, I said that in FET there are two types, that is basically MOSFET and JFET. In case of MOSFET, we have kinds of mode of operation, that is enhancement mode device and depletion mode device. So MOSFETs can be used in enhancement as well as depletion. So in case of this enhancement mode device, we have seen that it will be normally be in off state. So it is commonly used, one of the commonly used device and or mode of operation. So equivalent to normal open state, this I already told. So it does not conduct when gate voltage is zero. If there is no voltage applied, then it will be normally in off state only. So as and when we apply particular voltage, then there will be a temporary channel which is created between source and drain, and due to this the conductivity of channel will be started. So next is behavior is similar to BJT, except their terminals are different, emitter, gate and collector. Rest all the mode of operation is enhancement is almost same. And I also highlighted one particular advantage, major advantage, like ultra fast switching capability. Ultra means very huge, so very fast. So we can say that switching capability is high, and also the conduction. So then I say that there this a temporary channel will be created here, and this is the symbol. And coming to applications, it is used in obviously the electronic switching circuits and motor driver ICs, power electronics ICs and digital controllers ICs, so amplifier circuits and inverter circuits. So these are basically this all about enhancement mode device. So usually why it is mentioned is MOSFETs are usually operated here. So I just taken MOSFET as an example. There are also other enhancement mode devices, we can say. So this is all about enhancement mode device. So if there are any questions, please comment in the comment box. And if you would like to me to conduct any other topic session related to electronics and communications also, you can please comment in the comment box, and I will try to get back with that particular topic, and make it more simpler to understand. So if you are new to this channel, kindly again I'm saying please do subscribe to my channel, and press the bell icon to get the latest notifications. So till then, have a nice day. Thank you. Bye.